Hello, chemistry folks. This is going to be a little video guide for our Day 6 Build an Atom Simulation assignment. On the right side of my screen over here, I have the worksheet that you will be filling in your questions and drawing your conclusions on, and on the left side of my screen is the simulation. The atom part and the symbol part is what you will be using for this document. The bonus at the bottom of the page, I called an audible, and that's not actually a bonus. That's your CFU assignment, which is due Wednesday night. So if you do that bonus, you can just copy and paste it straight over, and that's going to be the exact same thing as your CFU assignment. The game, that bonus is the game at the end of the assignment. But for this part, you're going to be focusing on the atom section and the symbol section. So let's start with atom. Your simulation looks like this. It's got a whole bunch of things that it will tell you about an atom, and you need to check this box that says stable, unstable. Be careful, when you hit this reset button, it unchecks that, so you got to make sure that is checked. So you can take your bins here from your protons, neutrons, and electrons and construct atoms. So before we start, let's look over here. What parts go in the center of the atom? What is the center called? Well, this we know already from previous notes and readings and everything. The center of an atom is called the nucleus. Protons and neutrons go in the nucleus. Cool. So we can prove that to ourselves by clicking and dragging protons into the nucleus. So when I drag a proton into the nucleus, it tells me what element this is and highlights it on the periodic table. It tells me if it's stable or unstable if I have this thing checked. It tells me the mass of the atom, and it tells me the total charge. Remember from our readings about Rutherford and Thomson that protons are positively charged and electrons are negatively charged. So I take a negative electron and I put it up here. We have a balanced charge, one positive, one negative. But we're going to talk more about electrons later in this assignment. Question 2 says, explore until you discover a good rule for making the center of an atom stable. So for this question, we're going to be focusing on the center of the atom. Doesn't ask us anything about electrons, so I'm going to leave those out for now. So this is stable right here. So I'm just going to keep messing around, and I'm going to keep adding to it. Okay, so 1 proton, 1 neutron is stable. 1 proton, 2 neutrons is unstable. All right, but if I add another proton to it, it becomes stable again. Notice every time I add a neutron or proton, my mass number is going up by 1. So let me take out one of the neutrons. Okay, 2 protons, 1 neutron, that's stable. Let me add another neutron. Unstable. Another thing to note for later is that when we have 3 neutrons, that hasn't adjusted our charge at all. Neutrons are neutral and have no effect on the charge of an ion or atom. So I can take another proton and I can put that in there. Okay, 3 to 3, stable. Let me add in another neutron. Also stable. Let me add in another neutron. Now we're unstable. So when we have a considerable amount more neutrons than protons, it becomes unstable. And you'll notice that every time that I've added in a proton, we have moved up 1 element on the periodic table from 1 to 2 to 3. So I can add another proton in here. All right, so now we've added another proton. We've brought our ratio of protons to neutrons a little bit closer, and our nucleus is stable. Let me take out a neutron. Wow, those are even, but that's unstable. Okay, good observation. Let's put that neutron back in. Let's add in another proton. Okay, that's stable. Let's put in another proton. Carbon doesn't like that. 6 protons and 5 neutrons, not a good ratio, not a stable atom. Add in another one. Add in another one, still stable. Add in another one, and now we are out of balance with our protons and neutrons again. So I got to take another proton and add that back in, and now we're stable again. So I think at this point I have made enough observations and I've seen enough of the nucleus to write a general rule about how to keep the center of an atom stable. So I'm going to say that a nucleus is stable when there is a nearly equal number of protons and neutrons. So notice I say nearly equal because sometimes when they're equal, it's not actually stable. Like when I have 4 protons and 4 neutrons, that's still unstable. But if I add this in, I can stabilize it. But if I go too far, it's going to become unstable. So we don't have to have a perfect ratio, the exact same number of protons and neutrons, but they do need to be pretty close to each other in order to create a balance that stabilizes the nucleus between these positive and neutral particles. This is because positive particles repel each other. So like if you have 2 positive ends of a magnet and you try to push them together, they're going to repel. The same thing happens with these protons. The neutron's job in the nucleus is to create stability and to create an attractive force that overcomes the positive repulsion of the protons. So if we have a bunch of protons, we're also going to need a bunch of neutrons to keep that stable, in almost the same amount of protons and neutrons. So that answers question 2. Which brings us to part B. Fill in the table to identify 3 examples. These are examples that you can make yourself. So my first example, I'm going to do carbon. I already have 6 protons in there, or 6 neutrons, so I'm going to add in a couple protons, and I'm going to make carbon. So this carbon has 6 protons, 6 neutrons. It's got a mass number of 12, and its charge is plus 6. So I'm going to put in electrons to make this a neutral atom. This isn't required for this part of the question, but it doesn't matter. I'm just doing it. So when we have an equal number of electrons and protons, we get a balanced charge. So what's in the nucleus? Protons, 6, neutrons, 6. Screenshot of your atom. So if you're on a Mac machine, like a Mac computer, you'll hit Shift Command 4, and these little crosshairs will come up. You can then click and drag over a region of the screen to take a screenshot. And then that screenshot will pop up on your desktop. It'll be right on your desktop, and you can just click and drag that into your table. Boom, screenshot, done. If you are on a Windows machine, you're going to use the snipping tool, which will be in your start menu, which is a really nifty screen grab tool that's really easy to use and intuitive. And if you're on an iPad, you're just going to take screenshots, and they'll be in the camera roll of the device. So is this stable or unstable? It is stable. What element is it? It's carbon. So then we would make an unstable atom. It can be the same element, like you can make carbon unstable by taking out or putting in neutrons. Fill out the next row in the table, and then the last one is up to you. You can make it stable, you can make it unstable, it doesn't matter, it's up to you. So the rest of the lesson progresses at this same pace. When you're doing it on your own, you probably won't go as slow as I'm doing it right now and narrating everything out loud, but it's the same procedure. You get a question that prompts you to explore. So for the part 3, for question 3, what are some good rules about the charge of your atom? Okay, so at this point, we're going to be talking about charge. So I know I'm going to need to be able to see this thing, and I'm going to start adding in protons, neutrons, and electrons and seeing how each of those things affects the charge so that I can write a rule. We're looking for one sentence that explains each of these things. Another table where you're going to be putting in your screenshots and making atoms that now have a charge, either positive, negative, or neutral. Then you're prompted to look at mass. When we're talking about mass, we got to make sure that we have the mass number available so that as we add in protons, neutrons, and electrons, we can see how that affects the mass of the element. Finally, when we get to the symbol area, now you're going to be shown this symbol. So all of the same information is there, but it's moved around. So this is what it looks like actually on the periodic table when you're looking at one of the squares in your reference table. when you put in subatomic particles, the things are represented here. So the upper left corner is your mass, the upper right corner is your charge, and this bottom corner is not labeled, but it's red, and protons are red. I wonder if we can come up with any connections there as we're exploring this. Okay guys, that's the end of my little demo. The rest is going to be on you. If you have any questions, leave comments or send emails to me in the assignment sections, and I hope to see all of you very soon.